Okay, we are going to be finding the area of the region bounded by x equals 3 minus y squared. Notice it is the y that's squared, so it's going to be a sideways parabola, and then x equals y plus 1. So step one always is I'm going to go ahead and sketch the graph. So when you have x squared, it's a parabola that opens up or down. If you recall, when you have y squared, it's a parabola that opens sideways. So this 3 means that you're going to be moved to the right 3, that's the vertex. And then the negative in front of the y squared, that means that it opens to the left instead of to the right. So again, we just need the general picture. So if you need to plot a couple points, that's fine. So that's what it looks like. This is just an equation of a line. I'm going to go ahead and get y by itself. So y equals x minus 1, so start at -1, up 1 over 1. Again, just a general graph. It doesn't have to be exact. So it looks something like that. So the region bounded by both those graphs would be that yellow shaded region. Okay, before I start setting up an integral, I always draw my rectangle just to make sure I understand what the height and the width is. So notice if I draw the rectangle here, the height of the rectangle or the length is going to be red minus blue. Okay, but this one, look what happens when I draw the rectangle over here. Notice it's the blue, the top of the parabola, minus the bottom of the parabola. So notice the height of the rectangle changes. So that means you will actually need two separate integrals. So you'll need to do one on this left side here of the dotted line and then a little portion on the right side, which is fine. But instead of doing it that way, I'm going to go ahead and do it a different way. What if I draw a rectangle that goes like this? So I'm going to draw the rectangle going this way. So notice if I do that, the length of the rectangle, now it's sideways, is going to be the blue minus the red. And even if I draw it up here, it's still blue minus the red. Here, it's still blue minus the red. Notice that length does not change in terms of which two graphs you're looking at. So here, if I draw the rectangle this way, I only need one integral. So I'm going to do it this way because I don't have to split it up. Okay, if the rectangle goes this way, the thickness of the rectangle is now going to be dy, because right, this little piece right here is the change in the y value. This, the long piece, is going to be the length or the height. And to make sure that you get a positive number, you always want to do the bigger piece minus the smaller. So if we go right, left, the bigger number is always on the right side. So it's going to be the blue function, which is my parabola, minus the equation of the line, which looks like this. Notice I am using the equation and I need it in terms of y. The reason is the width of the thickness of that rectangle is dy, so if I'm going to use dy, everything else also has to be in terms of y. So this is the area of one rectangle. Now think about what we're adding. We're adding up these rectangles from the bottom here to the top. So that means your bound should also be your y values. So I need to figure out the y coordinates at these points of intersection. I can do this by hand pretty easily. I'm going to set them equal. I see a y squared, so I do need to go ahead and get the y squared, everything else over to one side. So I get to here, and it does factor nicely. So it looks like this is -2 and this is 1. So we're going to add up all the rectangles from -2 to 1. This is my integral. And even though there's y's in this integral, when you type it into the calculator, you just type it in with x's because it's still in terms of one variable. And you should get 4.5 if you want to check that in the calculator.